Yesterday we graphed the lines, and so today we're going to take and we're going to deal with take a line or take points and write the equations for the lines. And whenever we write them, we're going to write them in slope-intercept form. So the y equals mx plus b, we're going to be using that completely today. So reminder then that with the slope-intercept form of y equals mx plus b, that b is our y-intercept, and m is the slope. All right? And so we're going to be using that to find the equation for lines. So here we have a line, and we need to find the equation for the line, and we're going to write it in slope-intercept form. So we need to find the y-intercept and the slope. Right. So RJ, where's this graph cross the y-axis at? At 1. Okay, so our y-intercept, the value of b is 1. Now, when you're trying to find the slope, then you just need to find another point on the line. If the graph is going up to the right, the slope is positive. If it's going down to the right, the slope is negative. So we need to find another spot where there's an intersection point where it crosses on our grid. Okay? And they're nice enough to give us 2 of those spots. Right? Now, I always like to work to the right, so I'm going to choose this one that they've marked off for us. And what I can do, since I have it here, is I could make a triangle. Right? Because the one nice thing about the slope is it actually works in our favor when we do make a 90-degree angle there, because now I've formed a right triangle. So at different times you can, when it comes to finding the distance, because sometimes they want to know the distance from those 2 points. And you can use the Pythagorean theorem there. Right? So here we're going down 3, and we're going over 4. So our rise is -3, and we're running 4. Okay. Now sometimes you may end up with a fraction that you can reduce, and you need to make sure you do that. Okay. So we get y equals our slope, -3/4 x, plus the y-intercept, which is 1. Now, the x always goes in the middle. Okay, when you're writing the equation of a line, if it's a fraction, this x should always go here. If you write it like this, how many of you are going to write it on the line paper just like that? Anybody? Oh, good. Okay, because that's wrong. Because that looks like the x is in the denominator. Okay, don't do that. Okay. Or I've seen people do it like this. Okay, that's wrong also. So either the x has got to be in the numerator or in the middle, preferably just put it right in the middle. Okay? All right. So find the equation of this line. Okay? All right, so when we're given a line, find the slope, y-intercept, pretty easy. So if we're given points, to find the slope of the line, m is equal to the change in y over the change of x, Or we take the y values and we subtract them, divided by the x values being subtracted. So subtract the y's, divided by subtracting the x's. So the rise, y2 minus y1. The run is x2 minus x1. Now, here's the reason we do it in that order of the second y minus the first one, second x minus the first one. Okay? Because we always want the denominator to be positive, so we always want the bigger x value subtracting the smaller x value in the denominator. That doesn't always happen in the numerator, but in the denominator it does. So one of the things you need to remember is when you're doing this is that, okay, when I move from the first point to the second point, is it going up or is it going down? Because if it's going up, we know we're going to have a positive slope. When it's going down, it's going to be a negative slope. So we need to make sure we take that into account. So we're trying to find the slope of this line. So to find M, so we think of this as the first point here, this is the second point here. Because the first point has the x value of -1, second point has an x value of 2. All right. So -5 minus 1, -5 minus 1 over 2 minus -1. So we get -6 in the numerator, +3 in the denominator, so this gives us a slope of -2. But always the second one and then the first one, just to make sure you get the correct sign. All right, here they give us a bunch of points. Does it matter which 2 points I use? Since these are all on the same line, it does not matter. You can pick any 2 points. You could use the first one and the last one. You could use the middle 2. You could use the first and the third. You could use any 2 of them next to each other. It does not matter. Just make sure you're doing y over x. I decided to use the first point and the last one. Okay. And the one thing that happens when you do that, though, is you're probably going to end up with a fraction that has to be simplified. Okay. Now, if I would have chose the first 2, wouldn't have had to simplify that fraction. Okay. But it's up to you which ones you choose. How about this one? What's the slope of this line? Peter says it's 0. Okay, let's see if he's right. So I need 2 points. Let's see. I'll pick the y-intercept. I like that point. And I'll pick this one here. If you remember what we talked about yesterday, it did tell us if we had a horizontal line what the slope was. It either said it was undefined or they said it was 0. Okay, so Peter says it's 0. All right, let's verify that. So these 2 points I've got here, I've got the point 0, -2, and I've got the point 3, -2. Oops. All right, so change in y over change in x. -2 minus -2 over 3 minus 0. So in this case, we get 0 in the numerator and 3 in the denominator, which is 0. So he was correct. Right? So horizontal lines have a slope of 0. Vertical lines have a slope that's undefined because they have the slope that's undefined because what would happen? Basically, those two numbers would be switched. We'd have 3 over 0 instead of 0 over 3. And since you cannot divide by 0, we would have no slope then. But this does have a slope. The slope is actually 0. Okay, so you can't say it doesn't have a slope. You have to say the slope is 0. Okay? So find the slope of these two lines. Might like those better. If not, that's okay. Just as long as you keep them in the same order is fine. Okay. Point slope form is used when they don't give us, or if they give us the slope and a point, or all they do is give us points and they want us to find the equation of the line. Now they give us this point slope form, but when we're all done, we're going to put our final answer in slope intercept form. So this is for when they give us the slope and a point, or if they give us 2 points, or give us more than 1 point, we can find the slope and then use this formula to find the equation of the line. Now what would be really nice is if the y-intercept was one of our points. How would I know if the y-intercept was one of our points? How would I know if one of these points was actually the y-intercept? Anna? If x was 0. Okay? So if one of the points they gave us was 0 and something else, then all I would need to do is find the slope because they've already told me the y-intercept. Okay? Because that's when x equals 0. All right, so first we need to find the slope here. All right, so we got m equals, and I'm going to use 2 points next to each other in this case. Hopefully it will be simplified already. Now, which 2 points should I use? Well, I said 2 next to each other, but really, what 2 points should I use in this case? Okay. I'm going to use the ones where I'm working with integers and not decimals. Okay. All right. Would you rather work with integers than decimals? Okay. All right, just like you don't like working with fractions, right? All right. If we can avoid working with fractions or decimals, we will. So we'll use the first one, 1 minus -5. So -8, -5, we're going to use this point and this point here. And then the denominator, we do 8 minus -8. I'm choosing those because they're integers, no decimals to mess with. All right, much easier to divide then. So 1 minus -5 is 6. 8 minus -8 is 16. We simplify that and we get 3/8. So to find the slope, if you're given more than 2 points, we don't want to work with decimals or fractions if we can avoid it. So we will. So to find the equation of the line then, we're going to use point slope form. Okay. And so to use point slope form, we only use 1 point. Okay. The x and the y that are in that formula stay there. The x sub 1 and the y sub 1 are being replaced by the point we're going to use. So which of those 4 points should I use to find the equation of my line? And the answer is it doesn't matter. I could use one of these 2 in the middle if I wanted to, if I don't mind working with decimals. Okay? All right. I prefer not to work with negative numbers if I don't have to. So my choice for this one then is going to be this point here because they're both positive. All right? Easier to work with. So y minus y1. Okay? y1 is the y value for the point I'm using. So that would be 1. My slope is 3/8 times x minus x sub 1, which is the x value in the point I'm using. So we find the slope, put that in for m, choose one of the points we have available, plug that in for x sub 1 and y sub 1, and now we need to simplify it so that when we're done we have y equals. So we need to distribute the 3/8, and we need to move the negative 1 over to the other side. Both those things have to happen. All right, so I'm going to distribute the 3/8 first. And 3/8 times 8 is 3. And then I will add 1 to both sides. So we get y equals 3/8 x minus 2. Now, is there a way to check that? Is there a way to check to see if it's right? We could check it just like we check a lot of other things. We can pick a point, plug it in for x and y, see if it's true. Right? Or we could check out our technology. All right? Take out your calculator if it's not out in front of you. Go to your y equals. Make a fraction, right? Because it's 3/8. x minus 2. All right. Now, I'm going to show you the way I use instead of going to your table. Okay? Now you can go to your table, but your table is only going to show you 2 of those points, isn't it? Or is it going to show me all of them? No, it'll show me all of them, won't it? This one will, because they're all in yours. Right? So I can go to my table, look there, see if they're all correct. 4 negative 0.5. Let's see, if I go up here to negative 8, I get negative 5. Yep, that works. We're down to positive 8. Oh, negative 4 is negative 3.5. So they're all there. 8 and 1. Okay, I can check it on my table. Or, if you graph it on a standard viewing window, okay, and this is my preferred method here, okay, and you press the trace key. Right. Hey, that's nice. I found the y-intercept. Okay. Okay. Once I hit the trace key, I can put in any x value I want, and it'll give me a y value. Okay. So if I want to test to make sure I got the right one, if I put in negative 4, I get negative 3.5. Positive 4, negative 0.5. Positive 8, and 1. Okay, so you can hit the trace key and just plug in the x values and see what the y values are. You know what else? And I didn't tell you this in the last chapter. Okay, in chapter 1. Remember those problems we were doing in chapter 1 where it said find f of 3 and f of 5 and f of 2? All right? You could have put those in, put the function in your y equals, graph it like this, and then just hit trace and put in those x values, and it would have given you the y values. Thanks a lot for telling us that after the fact, right? Okay. Right. A way to check it, though. Right to there. All right, so first we find the slope. Then we plug the slope and one of the points into x sub 1 and y sub 1 and simplify that to find the equation of the line. All right. All right, so we're going to, all right. Okay, parallel and perpendicular lines. Right. How many of you have ever stood at the railroad tracks and looked down the railroad tracks? Okay. Nick does it all the time when he walks down over to Wyatt's, right? Okay. Are they parallel? All the way down? Even though it looks like they're getting closer and closer together? Okay, they better be, right? Okay, we know what happens if that's not the case. Mm-hmm. They could be switching tracks. They could be, you're right. Parallel lines have the same slope. Perfect, helps us out. Mm-hmm. Parallel lines have the same slope. So if I give you the equation of a line and ask you to find the line parallel to it, you're going to use the same slope. Perpendicular lines have a slope that is the opposite reciprocal. Okay? What do I mean when I say reciprocal? What does that mean? Okay. All right, you flip it over. All right, numerator is the denominator, and so on. The opposite means it's the opposite sign. So if my slope was 2/3, and a line perpendicular to that would have a slope of negative 3/2. Okay? Parallel lines have the same slope. Perpendicular lines have a slope that is the opposite reciprocal because they make a 90-degree angle. Right? So if you look at these two here that are perpendicular, all right, these make 90-degree angles here. So the slopes have to have the opposite signs for one because they're going different directions. All right? This blue one's going up, the red one's going down. Right? And then it just happens that the slopes then take the reciprocal. All right. So writing the equations of parallel and perpendicular lines. So we want to find the equation of the line in slope-intercept form. So y equals mx plus b of the line parallel to y equals 1.8x plus 3 and through the point 5,2. Great. They gave us the slope, 1.8. They give us a point, 5, 2. So all I need to do is use my slope or point slope form to find that. So we get y minus 2 equals 1.8 times x minus 5. Guess that smartboard ain't so smart anymore. Something just happened to it. Okay. So this is easy. Plug those three things in and simplify it. With our little pencil following us all the way through. All right, Cole, what's 1.8 times 5? Okay. All right, so we want to get y by itself, so we'll add 2 to both sides. So we get y equals 1.8x minus 7. Same slope, different y-intercept. Okay, so if they're parallel, the only thing that's going to be different about them is their y-intercept. Okay? If they're perpendicular, the y-intercept could be the same, or it could be different, but the slopes are going to be opposite reciprocal. All right, so there's a parallel line. Let's see one perpendicular. Find the line perpendicular to the line y equals negative 3/2 x minus 1, and through the point 9, negative 2. All right, so the slope for our line, since they're perpendicular, it is going to be the opposite reciprocal. So the slope of this line is negative 3/2. The slope of my perpendicular line is going to be positive because it's opposite sign. Take the reciprocal and I get positive 2/3. Okay. So now I have the slope and a point, and so we just plug them into the point slope form. Y minus negative 2 equals the slope times x minus 9. So we simplify it. Nick, what's 2/3 of 9? Okay, 6. Okay. Subtract 2 from both sides then. You get y equals 2/3 x minus 8. So finding parallel and perpendicular lines is easy. Okay. They give you the slope. Either it's the same or it's opposite reciprocal. And then you just have to plug it into the point slope form. So we got some easy stuff. Finding the slope, finding the equation of a line from a graph. Those are easy ones. All right, the other one's a little bit more difficult. All right, but you got to put it all together then. Here's your assignment.